Hello everyone, welcome to Flip-Flop Data. Today I will cover about one of the most important statistical topics, which is the cause of confusion for many. So before I proceed, let me tell you that this video is a part of the playlist and I will cover certain dedicated concepts and terms of hypothesis testing into each video of this playlist. I will take up the topic one by one so that you understand it from basics. So please do watch all the videos in the playlist to gain a complete understanding. So let me give you a brief on what areas I will cover in my entire hypothesis testing playlist. So I have divided this entire topic into 10 subtopics. Let me discuss on those subtopics. First will be definition of hypothesis and hypothesis testing along with their examples. Second will be types of hypothesis testing and their definition and details. Third, I will describe on the general procedure and the steps of formulating a hypothesis. Then I will show you how you can formulate null and alternative hypothesis. Fifth, I will describe concept of critical region and critical value. I will tell you about type 1 and type 2 errors. I will also make you understand the level of significance. Then coming to one-tailed and two-tailed tests. Then I will explain you one of the most important concept, that is p-value and its importance. Then last but not the least, I will show you the relation between confidence interval and testing of hypothesis. So let's get started. So this is our topic map. So out of those 10 subtopics, I have covered 4 of them in this video and rest will be covered in other subsequent videos of the playlist. So first, I will cover definition of hypothesis and hypothesis testing and giving you the examples of hypothesis testing. Then third will be types of hypothesis, that is simple and composite hypothesis, then null and alternative hypothesis. Then I will brief you with procedure and the steps of postulating a hypothesis, that is framing of hypothesis. Then last part of this video will be formulating the null and alternative hypothesis. So let's start with the definition of hypothesis. So how do we define hypothesis? Hypothesis is an assumption or a claim or a statement that we encounter in our daily life on the basis of some evidence which requires to be tested to see if it can be true or false. So we can break this statement into 3 parts. First is, it is an assumption made based on some proof, thought or evidence. Second is, it requires to be tested in order to establish with confidence if assumption is true or false. And third, it evaluates the strength of evidence from the samples considered. So next is, how do we define hypothesis testing? So hypothesis testing is the testing of truth or falsity of such claims or assumptions, that is the hypothesis, which we encounter frequently in our daily lives. So here what we do is we verify a claim about population parameter using a sample. So although the truth or falsity of a claim or statement is never known unless we examine the entire population, but practically it is almost impossible to do so. Hence, we take a random sample of the population under study and use that information contained in the sample for decision making, that is, making inferences in terms of whether a claim is true or false. So let me show you some real life examples so that you understand it better. So these examples are just an indicative and the list is actually exhaustive. So first, if you see, the air conditioning of certain brand saves up to 35% of electricity bill. Second, the motorbike of certain brand gives 60 kilometer per liter of mileage. Then third, a soap of certain brand kills bacteria and viruses to 99.9%. And then fourth, 95 out of 100 customers recommend brand A rather than brand B, etc. So all these examples are one or the other claim or an assumption or a hypothesis. And in most of these cases, they can be verified statistically. So now let me move on to the types of hypothesis. First is simple hypothesis. What is simple hypothesis? So hypothesis which specifies only one value, or rather I would say exact value of the parameter, that is, if you see mu equals 60 kilometer per liter as referenced in our motorbike example earlier. So this is a simple hypothesis. Also, if we consider statements like mu1 equals mu2 or mu1 minus mu2 equals 0 or sigma 1 equals sigma 2, etc. All these are simple hypotheses. Here mu1 refers to mean of sample 1 and mu2 specifies mean of sample 2, which we sample from our population. Then comes the composite hypothesis. Hypothesis which specifies not just one value but a range of values that the parameter may assume. It is called composite hypothesis. For example, mu1 is not equal to mu2 or mu1 is greater than mu2 or mu1 minus mu2 is greater than 0. All these examples are of composite hypothesis. Next comes our null and alternative hypothesis. So how do we define them? Null hypothesis. The statement or assumption which we wish to test for possible rejection under the assumption that it is true. So this again we can break into three parts to understand. So before that, let me explain you what is alternative hypothesis as well. So hypothesis which contradicts to the null hypothesis, that is, will be considered true only when null hypothesis is false, is an alternative hypothesis. So now coming back to null hypothesis. So let me break this into three parts to understand. First is we set up an assumption which we want to test. So let me give an example. Suppose I want to have an ice cream and I am very much interested in trying a new flavor like blueberry. I set up an assumption whether blueberry will be delicious or not. Second, I consider this assumption to be true initially. That is, I feel that blueberry flavor might always be delicious. So this is my initial assumption. Then third, I try to find out if my initial true assumption can be rejected under certain conditions. So I go ahead and taste it and find out that blueberry is delicious only when it is cold and solid, but once it melts, it does not taste good. Rather, it tastes like some cough syrup. So my range or sample space is starting with blueberry when it is cold and solid till it melts later while consumption. So here my null hypothesis becomes blueberry ice cream is delicious. And I do not reject or basically fail to reject null hypothesis till it is cold and solid. And my alternative hypothesis becomes blueberry is not delicious. That is, I reject null hypothesis when blueberry ice cream melts and it is in the form of a liquid. So I will say that acquaint yourself with two statements in statistics. First is rejecting the hypothesis, second is failing to reject the hypothesis, since this is used universally. So now, so for hypothesis testing, the claim and its complement are formed in such a way that they cover all possibility of the value of population parameter. Suppose our parameter can take values between 0 to 100. Then testing H0 and plus H1 should cover my entire range of 0 to 100. So rule of thumb for formulating null and alternative hypothesis is the statement which contains equality is the null hypothesis. That is hypothesis which contains symbols like equal to, less than equal to or greater than equal to is taken as null hypothesis. And the hypothesis which does not contain equality, that is contains not equal to symbol or less than or greater than symbol is taken as alternative hypothesis. So the null hypothesis in general is denoted by H0 and alternative hypothesis is denoted by H1. So to summarize here, H0 is no difference hypothesis as we assume it to be true until proven otherwise. We can never claim that H0 is proved or accepted as it can either be rejected or not rejected based on our initial assumption. And H1 is a statement which differs from H0. So if we fail to reject H0, our belief remains unchanged. If we reject H0, our belief changes. So now, moving further, let me elaborate on the steps involved in postulating the hypothesis. So first and foremost step is identifying the population parameter which we want to consider, that is mean, median, variance, proportion, anything, and set up an assumption about them. So point to note here is that the decision maker is only interested in making inference about population parameters, not in estimating the value of the parameters. Second, stating the hypothesis to be tested and writing it in words. Then comes the identified hypothesis has to be represented in the symbolical form. Then writing the complement or the opposite of claim or statement in the symbolical form. So let us consider an example of a motorbike over here, which I have already referenced earlier. So our population parameter is, in this case, is mean. And my assumption or the hypothesis is the motorbike of this brand gives the average mileage of 60 km per liter. Then the hypothesis becomes motorbike of this brand gives mu equals 60 km per liter, putting the same thing into symbolical form where mu is average mileage. Then comes establishing complement or the opposite of hypothesis, which becomes motorbike of this brand gives mu is not equal to 60 km per liter. Then further, I am representing the hypothesis in symbolical form. H0 becomes mu equals 60 km per liter and H1 becomes mu is not equal to 60 km per liter. So considering this example under study, we assume that the null hypothesis is true until there is sufficient evidence to prove it is false. A very important point to highlight over here is To say that null hypothesis is true, it is important to consider all observations of the sample under study. But for rejecting null hypothesis, only one observation indicating violation is enough. For example, if someone wants to test that humans have two hands, then to prove that this is true, we must check all humans in our sample. Whereas to prove that it is false, only one human who has one hand or no hand is sufficient. So with this, I conclude on this part. Please keep watching my videos. If you have any queries, please drop it in the comment section and I will answer them ASAP. Thank you. Don't forget to subscribe.